Welcome to this explainer. Today we're unpacking a really fascinating lesson on the mathematical foundations of zero and negative exponents, coming straight from the heroesmartacademy curriculum. Now, introducing letters and tiny floating numbers into math can feel pretty intimidating for 8th graders. But what this curriculum shows us is that these aren't just random confusing symbols. Actually, they're beautifully simple, highly logical patterns.
The source material actually grounds its whole approach in this scripture from 2 Corinthians 12:9. Just think about that for a second. It draws this really cool parallel to math, where a zero might seem like, well, nothing, and a negative might seem like a deficit or something lesser. But as we're going to see, these seemingly weak components actually possess the power to completely transform an equation. They literally hold the key to simplifying the most complex problems into elegant, understandable solutions. So here's our roadmap for today. Section 1, Power in the Small. Section 2, Why Exponent Rules Matter. Section 3, the Zero Exponent Rule. Section 4, the Negative Exponent Rule. Section 5, Let's Practice Together. And finally, Section 6, Education and True Peace.
Section 1, Power in the Small. Finding the hidden patterns.
Section 2, Why Exponent Rules Matter. This is really the key to real-world math and science.
Before we even look at the rules themselves, it's absolutely crucial to understand why they matter. Mastering these concepts doesn't just help you pass a test. It literally trains your brain to see flexible new patterns. Without these rules, you're going to get stuck when trying to simplify expressions in advanced algebra and high-level science. Think about scientific notation for a minute. When we measure the vast distance between planets or the microscopic size of human cells, we rely entirely on exponents. Computer scientists use them constantly to build complex formulas. So by grappling with these concepts right now, you are effectively doing push-ups for your brain, massively boosting your problem-solving power.
Section 3, the Zero Exponent Rule, or the Power of 1.
Okay, let's dive right into this first rule. Honestly, it's probably the most satisfying trick in all of algebra. The crucial point here is that no matter how complex the base is, raising it to the power of 0 simplifies it immediately to just 1. Any base, whether it's a tiny number, a giant million-digit number, or a complicated letter, if it has a 0 exponent, it just becomes 1. Now, the only exception to this is the number 0 itself, but for literally everything else, this rule is pure magic.
Check out this perfectly clear example. A 5 with a 0 exponent simply becomes a 1. You don't have to do any complex multiplication. You definitely don't have to pull out a calculator. You just see that tiny 0 hovering up to the right of the 5, and boom, it's a 1.
And this concept builds beautifully when we toss variables into the mix. The exact same rule applies, which just proves how incredibly consistent this pattern is. If you see x to the power of 0, it is simply 1. It completely doesn't matter what x represents in the context of your broader algebra problem. As long as x isn't 0, x to the power of 0 is 1.
Let's do one more super quick example just to lock in your confidence before we tackle the next concept. If I ask you to simplify 7 to the power of 0, what do you write? Exactly, just a 1. It really is that straightforward.
Section 4, the Negative Exponent Rule. Finding where the number belongs.
All right, now we're stepping up to the negative exponent rule. And here's the secret. A negative sign in the exponent doesn't mean a negative number, it's actually a set of directions. Think of this rule kind of like an elevator. The base stays the exact same, but the negative exponent tells you it belongs on a different floor of the fraction. When you see a negative exponent, it's basically begging you to take the reciprocal. If the term is on the top floor, the numerator, that negative sign says, hey, send me down to the denominator. And if it's already in the denominator, it says, send me up to the numerator. The negative sign isn't a value at all, it's a ticket to ride the fraction elevator.
When comparing these side by side, you can clearly see how the negative exponent visually transforms into a positive exponent once it drops to the denominator. On the left, we've got x to the power of -3. Looks a little weird, right? But let's apply our elevator rule. We put a 1 on top and drop the x down to the bottom floor. And once it arrives on the bottom floor, it's happy. The exponent becomes a +3. So x to the -3rd power is exactly the same as 1 over x to the +3rd power.
Let's look at an actual number example, where the 3 drops down, the exponent becomes a +2, and we easily simplify it down to 1/9. We start with 3 to the power of -2. The negative sign says take the reciprocal, so we ride the elevator down. It becomes 1 over 3 squared. And what is 3 squared? Well, 3 times 3 is 9, so our final beautifully simplified answer is just 1/9. Notice how the number never actually became negative? It just became a fraction.
Section 5. Let's practice together. Time for testing your new problem-solving power.
So the curriculum challenges students to actively apply what they know through independent practice. And the core message here is not to be afraid to make mistakes, because honestly, that's exactly how we learn and build those flexible mental muscles. The lesson provides these 5 practice problems designed to be conquered logically using everything we've just talked about. Number 1 tests that magic rule of 1. Numbers 2 and 3 require the elevator rule for both numbers and variables. Number 4 kind of flips the script. If the negative exponent is already in the basement, well, the elevator needs to go up. And finally, number 5 tests a really critical concept. Does a negative exponent actually create a negative number? I'll let you solve that one on your own.
Section 6. Education and True Peace, covering the heroesmartacademy philosophy.
Before we wrap this explainer up, the source material, which is part of the Godly Learners series, takes a real grounded moment to reflect on the actual purpose of education. The heroesmartacademy curriculum deliberately intertwines biblical morality with math education. It operates on the philosophy that simply being smart without a solid moral foundation eventually leads to painful choices. They pose a really critical question: what is the point of being highly educated and fully capable of solving complex exponential equations if you make bad choices that end up hurting yourself and the people around you? True intelligence in this view absolutely requires character.
The lesson concludes with Romans 8, verses 6 through 7, which promises peace of mind to everyone who keeps their minds spiritual. It leaves students with this incredibly thought-provoking final challenge. As you tackle tougher and tougher concepts in advanced algebra and science, what kind of mind will you cultivate to find true peace? It's definitely something to chew on. Thank you so much for joining me for this explainer. Keep seeking out the patterns in the chaos, and I'll see you next time.